All right, I'm going to go ahead and do the homework for 2.2. It's page 102, number 1, 3 through 6, 11, 12, 16, 18 through 20, 22, and 23. Starting with number 1. On his way to a local hunting and gathering convention, caveman Stony Grok picks up a rock, drops it into a lake, and notices that it sinks. He picks up a second rock, drops it into the lake, and notices that it also sinks. He does this 5 more times. Each time, the rock sinks straight to the bottom of the lake. Stony conjectures, Ura Nok Seblu, which translates to the rock sinks. What counterexample would Stony Grok need to find to disprove or at least refine his conjecture? Well, what could be is if his conjecture is all rocks sink, then perhaps he would need to look at certain kind of rocks that happen to be lighter or more flat or shaped more like a boat, hollowed out inside. There are some rocks that in certain shapes, certain kinds of rocks that could potentially sink. And so maybe he would need to be more specific about what kinds of rocks would always sink. Okay, number 3 through 6. Use inductive reasoning to find the next 2 terms in each sequence. 1, 10, 100, 1,000. 10,000. 100,000. Yep. And the fourth one, number 4, 1 over 6, 1 over 3, 1 over 2, 2 over 3. Oh, I see. So I'm going to rewrite this and with a base of 6. And so now, then the next one would be 5/6 and 6/6, which is 1. So that's 3 through 6. So that puts us to number 5. Okay. 7, 3, minus 1, minus 5, minus 9, minus, going down by 4. Minus 17, minus 21. 6. 1, 3, 6, 10, 15, 21. Add 2. Add 3, add 4, add 5, add 6, add 7, so 28. Add 8, 36. Okay. So in these ones, 3, 4, 5, and 6, finding the pattern. The more you do it, the quicker it'll come. Next is 11 and 12. For each exercise, use inductive reasoning to draw the next shape. A dot, a line segment, a triangle, a quadrilateral with 2 diagonals. What could the next shape be? 1, 2, 3, 4. Well, probably 5 dots. right? Because 1 dot, 2 dots, 3 dots, 4 dots, and the dots are connected. So a pentagon. It looks like the diagonals are drawn too. So let's draw all the diagonals. There's a possible one. This one, 3, 4, 5, whoa. Okay, so we got 2 by 3, and that becomes, so 2 by 3 becomes 4 by 4 becomes 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, becomes 6 by 5. Why is it that like it's shaded, like shaded, shaded, shaded? It's almost like it's rotating, so that the next time the shaded one would be up top here, and then you'd have some big block here. That's what it looks like to me. Well, that shaded one, first it's 3, then it's 4, then it's 5, then it's 1, 2, 3, 4, 5, 6, 7, 8, and it's 8. So first it's 3, then it's 4, then it's 5, then it goes to 8. Interesting, I wonder. Wow. That's fascinating. 12's going to take some thought. 2 rows, 3 columns. 4 rows, 4 columns. 6 rows, 5 columns. 8 rows. 1, 2, 3, 4, 5, 6, 6. So that is going up. 2, 4. Oh, look at that. 2, 4, 6, 8, 3, 4, 5, 6. Wow. This is going to be 10. Oops. 10 tall. That will be 8 wide. Or, no, wait. That's going up by 1. That'd be 7. There we go. 2, 4, 6, 8, 10. 7 with the shaded on top. Good. Wow. 16. Oh, this is fun. Well, we got a circle inside a square. 1, and then there's 4 of them, and then there's 9 of them, and then there's 16 of them. Oh, and the next one is going to have 25, and it's going to be 5 by 5. 5 by 5, and we'll have a total of 25 circles inside of squares. It looks like, too, that the diagonals are green, and they're kind of rotating. So first the diagonals go this way, and then the green goes this way, and then the green goes that way. So I'm guessing the green will go this way, and the rest of them will be yellow. And all the lines are green. That would be the next one in 16. What's the next number here? Then we have 18 through 20. Okay. Use the rule provided to generate the first 5 terms of the sequence in exercise 17 and the next 5 terms of the sequence, exercise 18. Okay, so 18. So we got 1, 3, 6, 10, and that's term 1, 2, 3, 4. That's n. And I need term 5, 6, 7, 8, 9. Okay. So first I'm going to go 5 times 6 over 2, which is 30 over 2, which is 15. Then I'm going to go 6 times 7, so 21. 7 times 8 over 2, which is that'd be 56, so 28. 8 times 9 over 2, which is 36. 9 times 10 over 2, which is 45. There we go. 19. Now it's your turn. Generate the first 5 terms of a sequence. Give the sequence to a member of your family or to a friend and ask him or her to find the next 2 terms in the sequence. Can he or she find your pattern? Generate the first 5 terms of a sequence. Oh, so maybe you could do something like, 1, 3, 5, 7, 9. Going up by 2, the next one would be 11. Or you could do something a little bit more interesting, like maybe add 5 and then subtract 2. Or add 4, subtract 2. And then add 4, subtract 2. Add 4, subtract 2. Okay. So there's now for 20. Write the first 5 terms in 2 different sequences in which 12 is the third term. Write the first 5 terms in 2 different sequences in which 12 is the third term. How about 10, 11, 12, 13, 14? Very simple. Or I could go make that 12, make that 10 and 8, 14, 16. Or maybe 24, 48. There we go. Cool. Next would be 22 and 23. Okay. The sequence 2, 4, 2, 6, 12, 20, 30, 42 is called a rectangular number pattern because the terms can be visualized as rectangular arrangements of dots. What would be the 7th term in this sequence? What would be the 10th term, the 25th term? So I have 2, 6, 12, 20, 30, 42. Looks like I have 1 row, 2 columns, 2 rows, 3 columns, 3 rows, 4 columns. And this is 1, 2, 3, 4, 5, 6 rows. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7 columns. So that is, let's see here, 1, 2, 3, 4, 5, 6. So that's 6 times 7. 7th term would be 7 times 8, which is 56. So you'd have 56 dots with 7 columns, 1, 2, 3, 4, 5, 6, 7, and then 8 rows. 1, 2, 3, 4, 5. So 8 rows, and all those filled in. The 10th term would be 10 times 11, which is 110. The 25th term would be 25. 25 times 26. And then 23. And look at the pattern. I'm going to erase this here. Okay, look at the pattern in these pairs of equations. Decide if the conjecture is true. If it is true, explain why. If it is not true, find a counterexample and explain why it is not true. 12 squared is 144, 13 squared 169, 103 squared 10609, 112 squared 12544. That's interesting. 21 squared 441, 31 squared 6961, 301 squared 90601, 211 squared 44521. If two numbers have the same digits in reverse order, then the squares of those numbers will have identical digits but in reverse order. If two numbers have the same digits in reverse order, then the squares of those numbers will have identical digits. Wow. So if two numbers have the same digits in reverse order, wow. Yeah, that is true. According to these examples, that is true. I have to find a counterexample making it not true. Oh, what's another example? You can go 14 squared and then look at 41 squared and see how those digits compare. So 14 times 14, 196. And well, 41 times 41 is 1,680. Oops. 1,681 is 41 squared. Well, that doesn't really work. That's not going to work. So this is false because I found a counterexample. Okay, interesting. Well, that concludes the homework. Let's go ahead and check work and see how we did. Okay. Looks like we're good.